Hi, so today in this video we're going to be covering chapter 5.5, which is the inverse of an exponential function. Let's just get right into it. If you remember correctly, the inverse of a function is when you just swap the x and the y's, right? Now, this is one thing that me and my instructor both agree on, as well as a bunch of other 1015 instructors. So this is the first semester that they're trying the new 1015 curriculum. There are a few things that we disagree with how the textbooks handles things. It's been mostly awesome. It's been great for preparing you for 1050. One thing that we think might be better is if we teach about how to switch from the logarithmic function to the exponential function, and from the exponential function to the logarithmic function. It will make your life way easier if you start with that, I believe. I believe it will make your life way easier with these oncoming chapters. And they do that in chapter 6.1.1, I believe, but not for chapter 5.5. So I'm actually going to, before I get into some of the inverse of a function, I'm going to sort of give a few examples where we're converting to and from. Again, it's something that we'll learn later, but I think it's really beneficial if we learn this now. One thing to know is when you have an exponent, a logarithm is the inverse of that. So the thing, the key to our mystery is we have base b to the exponent x is equal to your answer, right? That's going to be anything, right? So you could have something like 2 cubed is equal to 8, right? To switch into logarithm form, you write log base b to the a is equal to x. Now, the reason why this is really useful in math is because we don't know how to solve for an exponent. If you have something like 2 to the x and you're like, oh, I don't know what 2 to the x equals 8. Like, sometimes you'll come across really crazy looking ones. How it's useful to us is that it helps us find what our exponent is. Now, in this class, in 1050, in trig, in the classes that you are going onto, you will not learn how to calculators calculate logs, because it has to do a lot with calculus operations and stuff like that. You will learn how to plug a log into your calculator, and you will learn things like the change of base formula. I don't remember if we do that in this class or in just 1050, but you will learn those types of things, but do not stress over how to calculate a log. So if you see something like 10 to the x equals 7, well, there's not like an obvious answer there, because 10 to something is not going to give you 7. 10 to the 0 will give you 1. 10 to the 1 will give you 10. 10 to like something, we don't know what that something is. But having like log base 10 to the 7th equals x, your calculator can find that easy peasy. But we aren't going to cover how your calculator finds that. All we're covering is how to get this into the form, and how to manipulate the forms, and how to graph those forms. So don't stress over that too much. What we will stress over, which is not real stress because it will be fun, easy peasy. It feels weird at first, but eventually you'll get the hang of it. I really recommend just pulling up something like exponent to logarithmic function worksheet and just do a bunch of them. Pump them out until it becomes second nature to you, because it will so totally help you as we go through these math problems. So, for example, this one will turn into log base 2 to the 8 equals x. If you see something like log base 5 to the 25 equals 2, that turns into 5 to the squared equals 25. Just pump out a whole bunch of those. Just find a worksheet and just convert to and from and see if it makes sense also. That is my biggest advice to you. It's not an assignment yet. I don't believe that you do as many as you probably should in the homework ahead. It's really just something that will put you at a step ahead if you just do a whole bunch of those. It will make life really easy. I recommend doing just like a page of them. It's weird at first. It's not hard. It's not like you're doing any math. It's just learning how to convert between the two, and I super recommend doing that. Anyway, that's going to be very useful for us when we're finding the inverse of a function, because we're going to be putting x and we're going to be switching our x's and our y's, and we want to have x. We want to have y by itself. So in this example, we actually don't use that. But in this example, we have 3 to the x plus 1. We want to reflect about the line y equals x, which is about like this, right? To find the inverse. Basically, we're just doing the same that we've done with inverses before. I'm going to graph 2 points. I'm going to do 3, 0, because that's our y-intercept to our x-intercept, and then 1, negative 1 turns into 1, negative 1, 1 turns into 1, negative 1, and it sort of looks like this. And also, we don't cross 0. There's an asymptote at 0. So be careful with that. Careful with that. The way to do it with the reflection is just to say, oh, that's like right here. I don't know. It's kind of harder with the reflection. I just kind of like, I don't know why they bring that in. It's the same as saying, okay, I'm swapping my x, y values. I have a point at 0, 3, so that turns into 3, 0. I have a point at negative 1, 1, so that turns into 1, negative 1. What we've done for all of our other inverses, it doesn't change. Now we have the function f of x equals 2 to the x minus 3 plus 2 is graphed below. Same thing, we want to graph it, put a point on the vertical asymptote of the inverse, and then plot 2 points on the graph. So we would put an asymptote at, so if we were thinking like y equals x, it'd be like this, right? Our asymptote, yeah. So I'm basically gonna switch the points that I know. I have 3, so that actually stays the same. They're going to cross there. And then I have, where are some other points that I have? Let me just see. So we shifted to the right by 3, and we went up 2. So here's another point. We have 4, 4. No, wait a minute. I'm feeling like this is crazy, because oh no, it makes sense. So we have this. So now what it's going to look like instead is it doesn't cross this 2, and it will look like this, sort of. It's kind of funky, kind of weird. You just want to swap your x and y values and just sort of like, yeah. And if this x value and y value is negative 6 to the 2, that'll be like negative 6, 2. It doesn't cross there. Like, this is our new asymptote. It's kind of just like swapping x and y values. It's a little bit weird, but when we have asymptotes, it's a little bit weird. But an exponential function has a domain of negative infinity to positive infinity and a range negative 4 to positive infinity. What is the domain and range of its inverse? Really, we just swap them, right? So our domain is going to be this. Our range is going to be this. We just swap our domain. Our domain of our inverse is our range of our original function. Our range of our inverse is the domain. Wait, did I say that? Sorry. Our domain of our inverse is the range of our original. Our range of our inverse is the domain of the original. We just swap them. Whoops. Determine the inverse function of f of x equals 2 to the x minus plus 4. Now this is where we swap x and y. So let's turn this into a y. We have x is equal to 2 to the y plus 4. Now this is where things get funky. We're going to have to switch it into a log. So we have log base 2, because this is our base. Our answer is x in this case is equal to y plus 4. We want y by itself, so we can just minus 4 from both sides. So we have log base 2 to the x minus 4. Again, I super highly recommend doing a worksheet, because those worksheets are basically going to be exactly the same thing that we're doing, and then equals y. Yeah, this is our new form. This is our new equation of our inverse, and you'll do f of negative 1x. Yeah, it's a little weird, a little unfamiliar, but you will get familiar with it, and you will shine like a rock star. So yeah, if you have any questions, let me know. Have a good one.